Hello students, today you will learn about least common multiple or LCM. Let us first see what do we mean by least common multiple. Least common multiple is the smallest common multiple of two or more numbers. Least common multiple or LCM can be done by three ways. 1. Listing method. 2. Prime factorization. 3. Common division method. Let us first discuss about listing method. In listing method, we first list the multiples of the numbers, then identify the least common multiple. To understand this, let's solve one question. Look at this question. Find the least common multiple of 3 and 5. So, using the listing method, we will first list the multiples of 3 and 5. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. And the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. Now, we will write the first two common multiples among these multiples of 3 and 5. So, the first two common multiples of 3 and 5 is 15 and 30. Now, we will identify the least common multiple between these two common multiples. Since 15 is smaller than 30, the least common multiple of 3 and 5 is 15. So this is the listing method to find the least common multiple. Now we will discuss about prime factorization and common division method. Look at this question. Find the least common multiple of 20, 16 and 30. Let us first try to solve this question using prime factorization. So in this method, we will first find the prime factors of 20, 16 and 30 separately. So first let's do the prime factorization of 20. So first we have to divide 20 by the smallest possible prime number. Since the last digit of 20 is 0, we can divide 20 by the smallest prime number 2. When we divide 20 by 2, we get 10 as the quotient. Now, the quotient 10 is not a prime number, so we need to continue the division. We have to divide 10 by the smallest possible prime number. Since the last digit of 10 is 0, we can divide 10 by the smallest prime number 2. When we divide 10 by 2, we get 5 as the quotient. Now, the quotient 5 is a prime number, so we can stop the division here. So the prime factorization of 20 is done. Now, we will do the prime factorization of 16. So first, we have to divide 16 by the smallest possible prime number. Since the last digit of 16 is 6, we can divide 16 by the smallest prime number 2. When we divide 16 by 2, we get 8 as the quotient. Now the quotient 8 is not a prime number, so we need to continue the division. We need to divide 8 by the smallest possible prime number. 8 is divisible by the smallest prime number 2. So when we divide 8 by 2, we get 4 as the quotient. And the quotient 4 is not a prime number, so we need to continue the division. We need to divide 4 by the smallest possible prime number. 4 is divisible by the smallest prime number 2. So when we divide 4 by 2, we get 2 as the quotient. Since the quotient 2 is a prime number, we can stop the division here. So the prime factorization of 16 is done. Now we will do the prime factorization of 30. So first, we have to divide 30 by the smallest possible prime number. The last digit of 30 is 0, so 30 can be divided by the smallest prime number 2. When we divide 30 by 2, we get 15 as the quotient. And the quotient 15 is not a prime number, so we have to continue the division. Now, we have to divide 15 by the smallest possible prime number. 15 is not divisible by 2. So we will move to the next prime number, 3. Is 15 divisible by 3? Yes, 15 is divisible by 3. So we divide 15 by the next prime number, 3. When we divide 15 by 3, we get 5 as the quotient. Now since the quotient 5 is a prime number, we can stop the division here. So the prime factorization of 30 is also done. Now we will represent 20, 16 and 30 in terms of their prime factors. 20 can be written as 2 multiplied by 2 multiplied by 5. 16 can be written as 2 multiplied by 2 multiplied by 2 multiplied by 2. And 30 can be written as 2 multiplied by 3 multiplied by 5. Now we will circle the common prime factors. This 2 is common to all the numbers. So we will circle this. And this 2 is common to 20 and 16. So we will also circle this. And the number 5 is also common to 20 and 30. So we will also circle this. Now, to get the least common multiple, we will multiply the common prime factors and the remaining prime factors. But remember, we will count the circled numbers only once. So to get the least common multiple, we will multiply the common prime factors 2, 2 and 5 with the uncommon prime factors 2, 2 and 3. So 2 multiplied by 2 multiplied by 5 multiplied by 2 multiplied by 2 multiplied by 3 is equal to 240. So this is the prime factorization method to find the LCM. Now let's solve the same question using the common division method. In this method, we have to divide the numbers together by its smallest prime number. But if any number is not divisible together by the common number, we bring the number down as it is. So let's start. So by using common division method, we will first write 20, 16 and 30 in a row separated by commas. Now we will divide the numbers by the smallest possible prime number, which can divide at least one of the numbers exactly. All the three numbers are divisible by the smallest prime number 2. So let's divide them by 2. When we divide 20 by 2, we get 10 as the quotient. When we divide 16 by 2, we get 8 as the quotient. And when we divide 30 by 2, we get 15 as the quotient. The quotient 10, 8 and 15 are not prime numbers. So we will continue the division. So now we need to find the smallest possible prime number which can divide at least one of the numbers exactly. Both 10 and 8 is divisible by the smallest prime number 2. So we will divide by 2. When we divide 10 by 2, we get 5 as the quotient. When we divide 8 by 2, we get 4 as the quotient. And 15 is not divisible by 2, so we will bring down 15 as it is. Now, since 4 and 15 are not prime numbers, we need to continue the division. So now, we need to find the smallest possible prime number which can divide at least one of the numbers exactly. 4 is divisible by the smallest prime number 2, so we will divide by 2. Since 5 and 15 are not divisible by 2, so 5 will come down as it is and 15 will also come down as it is. And when we divide 4 by 2, we get 2 as the quotient. Here, 5 and 2 are prime numbers, but 15 is not a prime number. So we will continue the division. We can divide 15 by the next prime number 3. So we will divide by 3. Here, 5 and 2 are not divisible by 3. So 5 will come down as it is and 2 will also come down as it is. And when we divide 15 by 3, we get 5 as the quotient. Now, these three numbers are prime, but the prime factor 5 is common. So, we need to continue the division. We will divide by 5. 2 is not divisible by 5, so it will come down as it is. When we divide this 5 by 5, we get 1 as the quotient. And when we divide this 5 by 5, we get 1 as the quotient again. Now, the numbers are 1, 2, and 1. And among these numbers, there is no common prime factor. So we can stop the division here. Now, to get the LCM, we will multiply all the prime factors of the numbers. So the LCM will be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 2, which is equal to 240. Hence, the least common multiple of 20, 16 and 30 is 240. So this is the common division method to find the LCM. So students, that's all for today. Thank you.